So what we're going to do is we're going to talk about the differentiable, when it's differentiable and when it's not differentiable. What happened? Okay, so so what will happen is we are gonna walk through uh, differentiability and continuity. So and we're gonna talk about a couple of problems. So today is kind of just a very dry lectures, but it's a really from intuitive perspective, it's kind of important. So the notes are going to be probably the most important thing today because homework's not going to be like a lot of arithmetic. It's just understanding. So yesterday we talked about definition of derivative. So let's review of definition of derivative. And you have to know this. You have to recognize this. This is one of the. And trust me, we're not going to do derivative this way after the quiz, which is probably happen tomorrow or happen next couple of days. It's a small quiz is if you know how to do this, right? Whatever problem that you see on your homework. So what's the limits h approach 0 of f of x, f prime of x is equal to f of x plus h minus f of x over h. So whatever result you're gonna get f prime of x. F prime of x tells you slope at any given x value. So you can plug in that. So for example, x squared is going to get 2x. You can plug in 5. You're going to get 10. Then that's going to be a slope. But this is actually a good thing because actually I think it's more it's going to give you a formal of the derivative. But what if I just want derivative at a single point? So this becomes a alternative form. So alternative form of derivative. So what is alternative form of derivative? Well, it's going to be f prime of c is equal to the limit x approach c of f of x minus f of c over x minus c. And you're going to say, well, what's the difference between those two? This is going to find slope at a single x value. So it's going to find a slope at single x value. Not anywhere else, just a single x value. We're going to call this x value c. And in terms of graphing, it's really similar like before. In terms of graphing understanding, it's really similar before. Just say that if I have 2 points here, and I have something like this, right? And we're going to call this point is, instead of x, we're going to call this a c. And we're going to call this an x. It didn't matter, c or x. This is some arbitrary points. In this case, we're going to see c first, and then x second. And at this case, I'm going to have c comma f of c according to coordinates. At this coordinate is going to be x comma f of x. Now, I basically want to find out the slope of this black line. But start with the slope of the secant line, which is The secant line start with this. And eventually we're gonna shrink that C limit x approach to C is gonna be slower, and eventually gonna turn to the black line. So we find out derivative at a single C value, and that C value is a constant. Instead of variable, is a constant in this case. Basically, we just reduce that, because when limit x approaches C, basically we are taking this x and pull it towards C. If once it pulled towards C, then you can find slope at C. Are we okay? Okay. So that's just name of functions, and we're gonna try to find the derivative of this function at this particular point. So let's just say name a function you like, a quadratic one. So let's just say f of x is equal to x squared, I don't know, minus 5x plus 1, something like that. That's fair? Which C value you like?
Could it be any number?
Yeah. Let's do 5, okay. So so we want to find out the root of f5. C is equal to 5. Then what we're going to do is limit x approach to what? 5. Of f of x is going to be x squared minus 5x plus 1. Does that make sense? And we're going to figure out what f of phi is. F phi is equal to 5 squared minus 5 times 5 plus 1, right? So it's equal to 25 plus 25 minus 25 plus 1. So it's 1, right? Does that make sense? So minus 1 because of f of c. Good. And on the bottom is going to be what? X minus what?
5.
Minus 5. So it'll be limit. So remember, this is f prime f5, right? F prime f5. It's not x. F prime f5 is equal to this. X approach to 5. Then I'm going to get x squared minus 5x over x minus 5. Then it's going to be limit x approach to 5. If I approach it to 5, it's going to be 0 over 0. So what we're going to do is take out x of x minus 5 over x minus 5. And that's going to cancel out. And we're going to plug in 5. Then that's 5. Is that okay? Just alternative derivative. It's nothing special. Nothing special. So I'm going to ask you to do it. F of x equal to maybe 2x squared minus 5x plus 2, something like that, at f at c is equal to, I don't know, 3. Almost done? Dev's done? You got an answer? What numbers you got?
7.
Yeah. Sarah Z, you got it? You should get a 7. Did it right? Good? Katie, almost there?
I messed up something algebraically. I'm like, I don't know what I did.
Trevor, you got it?
I'm almost done.
Ethan, you got it? Good. So yeah, you need to know how to factor.
No, I messed up. I think I messed something up before the factoring because I know the fact.
I don't know what f of 3 is. Can somebody tell me?
5.
5. So it'll be 2x squared minus 5x plus 2 minus 5 over x minus 5? X minus 3, sorry. And the limit as x approach to 3. So it'll be 2x squared minus 5x minus 3 over x minus 3. Limit x approach to 3. So 2, 1, and 3, 1. And this is negative. So it would be limit x approach to 3. So it would be 2x plus 1 over x minus 3 over x minus 3. So this cancel out. 3, 6, 7. So 7.
Oh, yeah.
So that's the definition of alternative derivative. Now, why is the definition alternative derivative matters? Because you can take a derivative of this function. I mean, there's a formula for it, but it's kind of annoying. You just cannot take a derivative of these functions. So we're going to talk about why this function is hard to take a derivative. Well, first of all, there is no, and not only in anywhere, I want to find out, derivative at 2. Okay, I want to find derivative at 2. So we're gonna show you algebraic way to do it, and as opposed of the graphic way to do it. So here we got a 2 path we can choose. Now, first of all, let's talk about when this function is not differentiable first. So when function is not differentiable. When the function is not differentiable. Yes?
Would it be like literally anything but 2?
Huh?
Would it be like literally anything but 2?
Why is that?
Because if you look at it, it's like just a straight line. So if you actually try to find a single point, you can't.
Okay, good. I mean, we will talk about detail, but your intuition was correct. When functions not differentiable in many cases, so you might want to know what are those 3 cases is. I might just ask you on the test, just like continuous or intermediate value theorem. When functions not differentiable at those 3 cases, well, vertical asymptote for sure. Right? Vertical asymptote. Right? And another one is called sharp turn. Sharp turn. So that means some type of drastic turn. Like absolute values are one of them. Sometimes they have it more drastic called cusp. A cusp is actually belong to both. Belong to vertical tangent as well. So vertical tangent. Right. And another type probably you can have is probably some type of jump discontinuity. But I usually don't including that one because that's a very obviously it's just not continuous. It's not continuous and not differentiable. But the very obvious one is vertical asymptote, sharp turns, and vertical tangent. We're going to talk about this one here. And we're going to talk about there was a using definition and derivative to find the slope. So in this case, I want to find slope on the left side, which is you can find the slope of this, and you got to put in mind this is a good question to be tested. So 1, 2, and there are so many questions I can come up from here that. So this side of function we're going to call it x minus 2. And this side of function is called the opposite of x minus 2. Okay. So there are two sides. So what if I have limits x approach to 2 from the left? I want to find out the derivative from 2 from the left. Okay. Then I will use a function. Which function I'll be using? Well, I'll be using the negative x minus 2. Does that make sense? And I'm going to plug in 2 into the function, which is minus 0, over x minus 2. So that's equal to limits x approach to 2 from the left, negative x minus 2 over x minus 2. And if that cancels out, it's negative 1. So this means the derivative from the right. From the left, sorry. Now derivative from the right is same thing, but maybe just have some difference because 2 to the right. I may use positive x minus 2 minus 0 of x minus 2. And that's equal to the limit x approach 2 from the positive over x plus 2 over x plus 2. And that's equal to 1. Now derivative from the right is equal to 1. So therefore, f prime of 2 does not exist. Because left is not equal to right. Okay, if it's not equal to each other, they does not exist. Okay, so this is not differentiable, right? Are we okay? But when is differentiable? Okay. What is a requirement to be differentiable? This is also very, very important. I'm going to draw a big thing here. And on the bottom is going to be a, this is a very, very important. On the bottom is called limit exists. Limit exists when limit x approach to a from the left of function is equal to limit x approach to a from the right of the functions. On the bottom part is limit exists. Now, in order for the function to be continuous, remember those 3 requirements, right? It's on the last test. What are those 3 requirements? F of a has to define, because it has to be a solid dot. Second, what's second requirement? Or limit exists, which is we already have on the bottom. We don't have to rewrite again, but I'm gonna rewrite again. Limit x approach to a of f of x exists. So that just means two line connected to open circle. But the two line connected to open circle has to be equal to the closed circle. So it's third one, which is limit x approach to a of f of x has to equal to the solid dots. And this one is continuous. Then what is the last one here? Last one's called differentiable. Okay, differentiable is very, very important. Differentiable basically just have one more thing. I cannot fit in here, so I'm gonna write it here. It was limit x approached from the a from the left side of f prime x equal to limit x approach to a from the right side of f prime x. What's the difference between differentiable and limit exist? One is the prime, right? Prime means the slope had to equal from the left, equal to the right. If they do not equal to, they are not differentiable. So in this case, they are not differentiable because the left does not equal to the right. Now, do I have to do math to figure this out? Smart people says, I don't even need to use definition of derivative. I can just look at the slope, right? What is slope on this side? 1, right? And slope on this side? Right? So I could have said f prime of 5. That means I take a derivative, find out the slope at 5. It's just 1. By looking at it, visually I can understand that. Does that make sense? Visually I can just look at this. Look, if I know the absolute value graph, I don't even have to do the definition alternative derivative. And if I just say -2, what is that equal to? -1. How about f prime of 2? It's not 1. No. Does not exist. Why does not exist? Left does not equal to right. So therefore does not exist. Which is, look at here. It's not differentiable. It's not differentiable. Left slope has to equal to right slope. And we're going to talk about this more. But yeah, this is one of them. So we finish like vertical asymptote and maybe just something not continuous, right? Not continuous. So vertical asymptote is not continuous. It could be jump discontinuity. But vertical asymptote is a very obvious one because it's not point involved. Could be a hole, right? But it's anything not continuous. Basically, it's just a not differentiable. So you have to have this layer. So if the function is differentiable, that means what? That means you have all the prerequisites. That means all the bottom of pyramid is all exists. They had to be continuous. They had to be limit, they has to exist. They had to be all that. Are we okay here? I actually don't know if the stream has a sound. Now we're going to talk about last case, vertical tangent. Right? Vertical tangent is one thing that a lot of people are always confused. Is a vertical tangent differentiable and why not, right? So what is a time that have vertical tangent, which is this function, x to the 1/3. X to the 1/3 is a one weird function that it does not it's not differentiable at 0. But we're gonna show you why. First of all, do you guys know what the x to the 1/3 graph look like? Do you know what x to the 1/2 graph look like? Sydney is nodding. Anybody know which graph look like what? Let's start with x squared. Square root x. Do you guys know what square root x graph look like? Yep. It looks like this, right? But what's the x to the 1/3 graph look like? Well, it turns out x to the 1/3, you can cube root of negative number. So you do have negative side of the graph. But it's very similar to x to the 1/3, except a little bit more steeper. So especially right here. This part here, oops. This part here is so steep, if I draw a tangent line, it's going to be a vertical. Do you see that? What happened to slope is vertical? It's undefined. So let's check if they're undefined. Good job, Ethan. So limit x approaches 0, and we're going to use definition alternative derivative. So x to the 1/3 minus 0 over x. And guess what? That's going to be limit x approaches 0 of x to the 1/3 over x. Which one's larger? The bottom part is larger, right? So can I say limit x approaches 0 of 1 over x to the 2/3? Does that make sense? No? That don't make sense, Kevin?
No, I'm saying it doesn't make sense to do it.
Huh?
I'm saying it doesn't make sense to do it.
Does make sense or doesn't?
Yeah, it does make sense.
Okay. So then what happens if approach 0 on the bottom? If the variable is on the bottom but it's approaching 0, what will happen? What do you think the value is going to be? Well, it's 1 over a number, right? 1 over a number is going to be what? It's going to go reach past infinity. Why is it reach past infinity? Because it's 2/3 power. 2/3 power tells me the value always going to be positive. If it's always positive but it's getting smaller. But think about 1 over a small number, right? What will happen? 10, 100, 1,000, right? So it's going to positive infinity. Now, if a slope is positive infinity, that means slope is almost vertical. It's actually vertical. It's vertical. We don't infinity. That's why sometimes we say infinity doesn't exist, because slope is vertical. That means does not exist. We know that from algebra 1. Do you remember that? Slope of this line does not exist. Slope of this line is 0, right? This is a positive, right? This is negative. You should know all this stuff. But if it's vertical, it's going to not exist. So therefore, we just verify something. Vertical tangent is one of the part that does not exist. Yes, Caroline? Just stretching. I know, second period in the morning. So yeah, so those are the things that you should understand. Remember, this pyramid is going to come back test all the time. The situation is not differentiable. It's going to test all the time. I will put it on a test. Just simple things like this, you have to understand. Because if you don't build from the conceptual understanding, you're not going to do well in calculus. If you just know how to do arithmetic, you're not going to do well. So you have to have that conceptual understanding. And we spend a lot of time today talking about those conceptual understanding, because first, we talk about how to use alternative form. That means I can take a derivative at single points. And you're going to have some homework question about this. But mainly, you have to understand is, Is any easy way to find the derivative of absolute value? Yeah, graph it and look at the slope. Graph it and look at the slope. See what happened here, what happened here, what happened in turn. Well, when it's turn, the sharp turn does not exist. And the condition to be differentiable. Condition to be differentiable, it has to be, limit has to exist. It has to be continuous. And differentiable means slope from the right has to be equal to slope from the left. So slope, right slope, or left slope, sorry. Left slope has to equal to slope from the right. If they don't equal to each other, it's not work. So the best way to think about roller coaster. It's that vertical tangent. Roller coaster can have vertical tangent. That's the only thing that is different between roller coaster and differentiable. Otherwise, you don't want to have a roller coaster go like this, right? Even that is going to be disastrous. But you can have roller coaster like this. That's fine. You can have roller coaster go like this. That's fine. It's not sharp turn. Anytime you create any type of sharp turn, even just little bit, even by inch, that slope on the left does not equal slope to the right. Guess what? That's not differentiable. If this is like, say, 1.2 and the other side is 1.3, guess what? It doesn't work. Because most changes, your roller coaster does not work, so therefore it's not something that will functional. So a differentiable is like a functional roller coaster. The way I kind of think about it, differentiable is a functional roller coaster. Being continuous is just a connected roller coaster. Being differentiable is going to be smooth, completely smooth. Limit exists just means they connected but with a hole. But that's not good.
Can you go down a little bit?
Sure.
Why'd you put 1 there?
Why'd I put 1? Oh, this does not exist.
No. The limit as approaching 0 is equal to 1 over.
Oh, because I simplify x to the 1/3 and x. So I just use the quotient rule, so it'll be a to the m over a to the n equal to a to the m minus n. So it's equal to whatever. So it's equal to negative 2/3, right? Can I change to 2/3 on the bottom? I had one viewer. I don't know who that is. Any questions so far? Okay, that'll be all for today.